ஒரு சவுண்டும் வரலையே. ஆஃப் பண்ணிட்டீங்க.
Sir, very good morning. Can you able to start the session? Permissible, sir, good morning, sir. Can you able to start the session, sir?
Yes, I think better to go ahead. Yes.
Okay, sir. Thank you. Thank you for it. Very good morning, my dear leaders. It's been a pleasure to meet you all once again in this Saturday webinar on skill enhancement of our industrial persons. It's been a pleasure. We have been in the 27th week. It is a great pleasure, and by your supports, we can able to reach this milestone. Once again, thanks for it. IINVTY has been an organization which has been formed in a vision of invention, innovations, and inspirations. IINVTY has been having three wings of auditing, of research and training. In training, we have been having two wings, corporate trainings and also the statutory requirements trainings. We have been doing different kind of trainings based on the needs of the corporates. This is our 27th week, as I have been indicated. Today, we have been going to talk about the industrial safety requirements, towards the electrical. With this, I've been having a more pleasure to introduce our renowned trainer, Mr. Perumal, sir, who's been having 3 decades of experience on this safety field. I've been requesting all the participants to put on mute. Put your.
Okay, sir.
Okay, you are there in line?
Sir, yes, sir. I've been live, sir. I've been there. Okay.
Shall I continue?
Sure, sir. I've been much pleasure. We have been much pleasure to introduce yourself. We have been having 3 decades of experience in this particular safety field. We have been designed. We have been designed in such a way that the electrical safety updates have been shared with you. With this, Perumal sir, you can able to take the session.
Thank you, Satya. Good morning once again, gentlemen. And there are some participants who are joining with us on all Saturdays. And first and foremost, I request whoever is keeping their mic on, please put them in mute so that it doesn't become a disturbance for others. If my voice is not clear or it is not audible, please either you can raise through the chat box so that I will take some corrective action. For that reason, even I put my video closed. I kept my video closed so that the internet quality can be better. Is my voice is clear so far, Satya?
Yes, sir. Your voice is clear.
Presentation.
Thank you, madam. Thank you. Thank you. Now, gentlemen, and today, as part of our Saturday program, we have chosen for electrical safety. Yes, still somebody is keeping their mic. Okay. Now, when we talk about working at height, you all know what is working at height, correct? Whatever the work we do above 6 feet and above, what are the work you are carrying out at a height of 6 feet and above, those are called as working at height. Similarly, what is confined space in general, that also you all know, right? If there is, if the confined space is related to the excavation, if there is a excavation for more than 1.4 meter or 1.2 meter in some
அது ஃபைல்ல இருக்கும் இல்ல அது என்ன இது அந்த என்னோட இது இருக்குல அந்த ஹெல்மெட்ல வச்சிருக்கேன் ரூம்ல
still somebody is keeping his mic on. Gentlemen, please put it in mute.
Yes, sir.
Similarly, the moment we talk about the confined space, we know that if it is related with the excavation, and if the excavation depth is more than 1.4 meter or 1.2 meter, in Middle East it is taken as 1.2 meter. In India, we are considering this 1.4 meter. So the depth is more than that, then it is termed as confined space. Now, do you have any such kind of parameters for electrical when it is when it comes for electricity, like we have a permissible exposure limit with regard to noise, with regard to exposure to H2S, or with regard to exposure to SO2 or CO or CO2, etc., etc. There is a limit, permissible exposure limit. Is there any such limit we have with regard to electricity? Gentlemen, the participants can throw their ideas or views. Is there any such limitations we have with regard to electricity? Rajan said no. Correct, no? We have no such limitations for electricity. Whether it is 1 volt or it is 1 kV, we have no such limitations where somebody can expose to the electrical energy safely. Correct, no? There is no such limits. Now, then what should I do? How can I do my job? And just to go get into the before we proceed further, I hope some of you might have experienced electrical shock during your childhood days or college days, or even part of your work or at home somewhere. Some of you, not every one of you. Some of you might have experienced electrical shock. Correct, no? Like when you are learning how to drive cycle. Now cycle is put in a corner anyway now. When you are about to learn your bike, when you are know how to drive your car, or you take any case. Take the case of swimming or take the case of sports. Anything when you want to learn, there will be some kind of personal experience, correct? Similarly,
Excuse me, sir. Sorry for the interruption. Hello.
Tell me, madam. Tell me.
Sir, your slide is not moving, sir. It was still same.
I am not yet moved the slide. I am still in electrical safety. I am just giving.
Okay, sir. Thank you, sir.
I am just giving an intro only, so that I want the participants to visualize or feel themselves that why we talk about electrical safety.
Okay, sir.
I am just aiming for that point.
Okay, okay, sir.
Some of us might have experienced with electrical shock. Anyway, I'm just sharing my personal experience. When I was studying sixth standard, yes, I finished my 10th in 84. So 6th standard, just another 4 years already, somewhere 80s. So I just use a tester to check the voltage, just to check in the socket whether is there any current available or not. The moment I touched at the end, when I counted the circuit, the light in the tester was glowing. Now I thought that current is passing through me, the voltage is passing through me, and I am not experiencing shock. So those days, CAMI tester is very famous. CAMI, CAMI tester. Those days. So and the tester will not have the protective sleeve till the tip of the tester. It will be just somewhere off only. So I thought, okay, when I am touching at the back, nothing is happening to me. Why not me touch in the tip in the front? So I touched and experienced personal shock. Similarly, that is done when I was studying 6th or 7th. I don't remember the year exactly, but that experience reminded me what a electrical shock, what it can cause. Okay. So similarly, even all of us, those who are especially electricians, they might experience several times what is shock, right? No? So today we are going to discuss about electrical safety in case of industry, how we are going to face this. Okay. I hope I just took a couple of minutes for giving an intro. So now I'll move on with the slides. So today we'll be just covering about what are the major electrical hazards, what are the types, how we can protect those hazards, what are the responsibilities of employer with regard to the state and central regulations to protect their workers from electrical hazard. So this one, I hope every one of you know what is electricity. Electricity is nothing but the movement of free electrons between atoms. And it is related with current, resistance, and voltage. Right? And gentlemen, wherever there is a doubt, please feel free to ask through the chat box, so that some kind of reply can be given. If I know, we'll clarify then and there only. So how this energy, electricity, is moved from one end to another end through conductors. Conductors such as metal that have little resistance to electricity, and these conductors are protected with the help of insulators. Dry wood, rubber, glass, backlight, all those things are having very high resistance to electricity. Grounding, a conductive connection to the earth, which acts as a protective measure, so that the impact of the energy onto the human or animal is reduced considerably. These three terms are which are related with electricity. Now we'll just get into the business right away. What are the electrical hazards? What are the different types of electrical hazards? The simple memory clue is be safe. The simple memory clue is be safe. B stands for burns, electrocution, shock, arc flash or arc blast, fire, and explosions. These are the various types of hazards which are related with electrical energy. And almost all of us know, without electricity, nothing is achievable in today's industry. Whether even you take the case of industry or even a domestic purpose also, the electricity, this electrical energy is become part of our day-to-day life requirement. We know the hazard and we are living with the hazards, right? And here I just shown couple of links which are taken from OSHA. Yes, OSHA, you all know, Occupational Safety Health and Administration. They have a variety of animated videos with regard to electrical safety. On your free time, you can just Google it and have a look. Now we'll be discussing about one by one. Burns. The most common shock-related injury is burn. And burn, when you talk about burn, we all know thermal burn, chemical burn, and this is a burn caused become from the source of electricity, electrical arc flash or thermal contact. Because the conductors, if the right conductors are not used for the transfer of electrical energy, the conductor become extensively heat, and that also can become a source for causing a burn injury. Electrocution is fatal. Electrocution is fatal. This aspect we might have come across if you happen to watch news on a daily basis, that there are some electrical workers, either from EB or from the contract laborers, when they are involved in rectifying some electrical problem, they get electrocuted and instant death occurs then and there. I don't know how many of you saw this video clip. It is this was circulated in the WhatsApp only, social media only, sometime back, maybe a couple of months before. That one gentleman was trying to save a bird from a live electrical line, the lamp post. This fellow climbed the lamp post. He was using a stick. Yes, when you look at the video, we could assume it seems to be a stick. He saved the bird, but the stick was not that dry enough. That became a conductor, and this fellow who was holding the post fell from there. He got electrocuted, fell from there, and instant death. Even though he could save the bird, but he could not save himself. Okay. So electrocution, most of the cases, it is fatal. Shock. Here only I was just sharing my experience. Even though those at that age we were very strong. At that age we were very strong, so there was no much impact with the electrical shock for me. All like I felt there is a strong, there was some strong force where I could remove my hand. I just removed my hand from the tester, and that became a learning experience for me. So from those days onwards, whenever I handle electricity, even for changing bulb, my first job is to always switch off, then go and change the bulb. So when body becomes a part of electrical circuit, as you all know that our body is a very good conductor, even though the resistance varies from person to person. Even though when you are wet or dry, where the resistance vary, of course, vary. When you are wet, the resistance is very low. When you are dry, the resistance is very high. It varies from 1000 ohms to 10,000 ohms for the human. And even then we have resistance, but our body is a very good conductor. So shock we observe when you become part of electrical circuit reflects response to the passage of electric current through the body. Okay. Arc flash or arc blast. Those who are in industry, especially industries, they might have come across this word, arc flash or arc blast. There is a sudden release of electrical energy through air when a high voltage gap exists and there is a breakdown between conductors, and it gives off thermal radiation and intensive light that can cause burns. The temperature can go as high as 35,000 degrees Fahrenheit. The smallest case where you can experience 500 5,000, 35,000 degree Fahrenheit. We all know our body temperature is somewhere around 98 or 99 degree Fahrenheit. And the moment you cross 100, 101, 102, you know how we are suffering with the temperatures. Correct. The moment it crosses 100, 101, 102, whether it is 101 or 102, we feel so much of tiredness. We feel our body is extremely hot. Just imagine if there is an arc flash or arc blast, the temperature can rise up to 35,000 degree Fahrenheit. Now, what is then arc flash boundaries? What is arc flash? We saw now. What is arc flash boundary? If you see the red color, the red inner circle, then at the core you can find a block small circle. That is an exposed conductor. That is an exposed conductor. Here you can see that. Here you can see, right? This portion. Then the first inner circle is a restricted space. The second inner circle is a limited space. And at last, the dotted lines which you can see, that is the arc flash boundary. That is the arc flash boundary. So when we are handling a high source of electricity, high energy, I mean 10 kV, 12 kV. So there we need to keep a safety distance according to the space. What you can see in the screen now, restricted space or limited space. We need to allow only qualified and competent persons as they go closer to the source. With the recommendations, what is given in the risk assessment, with the necessary PPE. Okay. And if you can see where the moment even if you happen to be in the third zone, up to second degree burns are likely to occur. As we all know that first degree, second degree, third degree of burn. First degree of burn where the recover possibilities are there. Second degree maybe or may not be. Third degree burns, the recovery is not at all possible. Now, if there is a arc blast, how much temperature we saw now? There can be a temperature rise for 35,000 degree Fahrenheit. The sound can go up to 145 decibels at 2 feet distance. Even though you are standing at a distance of 2 feet, the sound can be almost 145 decibels. I hope some of you might have experienced during monsoons, especially during rainy seasons. That suddenly you might be hearing this. Suddenly you will find that completely, your power supply at home will go off, and someone will be telling there is some transformer blast in the third street, right? I hope some of you might have come across the statement saying that there is a transformer blast in the third street. That is true. Even at your home, you can hear some noise apart from the thunder. Apart from the thunder and lightning, you might have heard the statement that there is some noise, big noise here. There is a big noise. So you might have heard, you might have listened that noise, and someone might have saying that it is a transformer blast. Transformer blast. Okay. And if it is with the arc blast, it can go up to 145 decibels. Even the jet engine can produce 132 decibels at 200 feet. But in case of arc blast at 2 feet distance, it is around 145 decibels. And you all know what is the permissible exposure limit of noise for a human. Correct, no? It's only 85 decibels. more than 85 decibels, you may have to wear a single hearing protection or double hearing protection. Arc blast. Somebody was asking about whether it is arc blast or arc burst. It is arc blast. High voltage arcs can also produce considerable amount of pressure waves by rapidly heating the air and creating a blast. See, if there is, just imagine 35,000 degree Fahrenheit of temperature can rapidly interact with the air, that in turn produce a huge amount of pressure waves. Fire. And this instance, many instances you might have read through newspaper or listened from the news that there was some fire in the apartment. The recent news, what I remember, husband and wife, both were both were sleeping in a room, AC room. So the ultimate cause, poor conductor, because of electricity. The fire caused because of electricity. There was some overheating. So because of that, cable got fire. From the cable to another source. From that source to another source. In turn, the entire flat, the entire room might have caught into fire. See, the many instances, even if you take the case of Chennai recently in T Nagar, I think last year, there was a fire. It was related to the electricity. Most of the industrial fires are related with electricity. Either overloading or not tripping take place, heating of conductors. There are some or other problem always related with electricity for most of the case of fire. Problems with cord, plug, receptacle and switches, etc. etc. Explosions occur when electricity ignites explosive mixture of metal in the air. See, this is a secondary impact. The primary impact is the fire, and the fire in turn it ignites the explosive source, the explosive mixture in the air, which is available in the air. Like if we are happen to work in a flammable atmosphere, if you are happen to work in a flammable atmosphere, like if it is in the oil and gas sector, if you are happen to work in a flammable atmosphere, and there always a mixture is readily available for catching fire, which can catch fire. And if there is a suitable ignition source available, if both are joined together, then it can become an explosion. Here also there are some cases are given. There are some case studies are given. These case studies, we actually see to discuss all these case studies, to discuss on the regulations which are demanded by the central or the state. We need to take a lot of time. So here I am just giving you the case 1, case 2, what has happened. And these things you can just check from the Google. It is available in OSHA website. You can always check that worker electrocuted when the ladder came in contact with overhead power line. Worker electrocuted when mass came in contact with high voltage overhead lines. Because I just taken 3 cases only for discussion. Worker changing energized ballast on light fixture was electrocuted and fell onto the concrete floor. See, here the shock, the electrocution or the shock, whatever he got might be less, but if he's falling from such height, if he's falling from a great height, the secondary impact can cause a fatality. Even though because of electricity he may survive, but the secondary impact that can be a reason for his fatality or major injury. Year by year, as per ILO also, even if you take our websites also, TNEI, Tamil Nadu Electrical Inspectorate .tn.gov.in, if you check that also, or you check the central website also. Year by year, the number of electrocutions are in rising trend only. Year by year, the number of cases related with electrocutions are in rising trend. That you can check from the statistics. Yes, one thing you can simply say that saying that there is a huge development of industry. The number of sectors are just expanding. There are more companies are coming. That is the reason there are more amount of work is taken. More people are involved. That is the reason. Those things are one part. But the main reason, there is a strong negligence with respect to safe work practices. Like the 3 cases, what you are studying. See, the one example that this gentleman is trying to lift a ladder, is lifted a metallic ladder, unknowingly touched the overhead line, and he became a conductor and get to the ground. So circuit is completed. Then this gentleman exposed to electrical shock or electrocution. The similar thing will happen with the cranes. Like if somebody is using Hydra, you are using a Hydra. So when Hydra is used, we all focus on the load. We focus on the lifting tackles. We focus on the rigging line. We focus on the tag line. We look at is there any obstructions nearby? When you are swinging the load, is there any obstruction? But we tend to forget the topmost part of the telescopic boom. See, when you're extending the boom, at the extreme end, what is available, that we have to see. In some cases, you can see anemometer. In some cases, you can see something else. And if you happen to lift with the main hook, you'll forget about auxiliary hook. There are some cranes with both the hooks, right? Main hooks are available, auxiliary hook are available, and you are lifting a load with main hook, and you forget where the auxiliary hook is there. Even though you have fully wound up the auxiliary hook, but the tip of the auxiliary hook can touch the overhead line. Okay, so these things we should keep in mind. The covering on an overhead foul is primarily for weather protection. Therefore, workers need to know that if they touch power line, covered or bare, that is probable. See, the covering of power line, that if especially in those who are in a crowded place, that they may be knowing. The EB line will go very close to your house, correct? No, the service line you're taking for your home from the EB lamp post or light pole, that will be very close to your house, so that the common precaution, what do? We take a PVC pipe, cut the pipe, insert into the wire, so that act as a protector for you. Correct? No, in some cases they do. Even if you take the, if you remember the movie, Tamil Ken Wonder Elthom, there was a movie, where Nabil was the hero. And Nabil mother is Urvasi. They will show a scene in the movie that she will hang a wash clothes onto a power line. Correct? Now it is neutral, only nothing will happen, something like that. So in some cases, some closed area, dense area, where you can see EB lines are running very close to your home, very close to the home. Okay, those areas we got to be very careful. Even if you, this was shown in the news itself, that people are residing below transformer area, that you might have also seen. You might have seen in city also, that some people, those who are homeless, those they don't have any home, they start residing below the transformer. They're putting themselves in big danger. Okay. Now, when you are in contact with a energy source, a live source, your body becomes a conductor, and when you are touching the ground, there you are completing circuit. So when you are completing the circuit, you are become part of the circuit, and we get through the electrical shock. And then, and depending upon the amount of voltage, depending upon the amount of current, the time taken, the severity also varies. Okay. The severity and effect of electrical shock depend on a number of factors: pathway through the body, which route it is taking for travel, amount of current, length and time of exposure, whether skin is wet or dry, and you can add age also. Age also another one factor, that if you the likelihood is always with respect to the age. Lesser the age, the impact is less. More the age, the impact is more. And even if you are wet, we become a best conductor because water is a great conductor, allows current to flow more easily in wet condition and through wet skin. Gentlemen, so far, I hope I am clear. Wherever I am, if you are not getting clear or you have some kind of disagreement, please always raise your queries to the chat box. Now, in the beginning, I was talking about the permissible exposure limit for shock. How much electricity we can take. Here is a very simple a table is given. What will happen below 1 milliampere? What will happen with 1 milliampere? What will happen with 5 milliampere? I'll just move on to the next slide. In the next slide, you can see, you can understand better. Okay. This graphical representation will give us some more clear picture. 1 milliamps, you can just feel it. 5 to 10, we can't let go. 20 to 50, possibly fertile. 60 and above, probably fertile. Now, I don't know how many of you are really experienced with electrical shock. Sometime back, I was sharing my experience. You remember that when you take the cells, whether AA or AAA or Class D, Class C. Class D normally used in torchlights, correct? No, Class D cells are used in torchlights because these things I just seen when I was when I was saying I seen from others also. They will check the quality of cell, whether it is working, it is in good condition or not. Correct? No, just by licking the positive side of the cell. Yes, if you take the cell DC cell, it has two terminal plus and minus. So they'll just touch by one. They'll hold the cell, touch the bottom, and try to lick the tip. And with that, they will tell the quality of cell. There are some people. They will tell, yes, this can run for at least tonight. This can run for at least next 2 days. Huh? I don't know how many of you have come across this. Yes, I have seen people. I have seen people using this technology in identifying the capacity of the cells, especially Class D, which are used in torchlights. Huh? Like the one which is carried by the watchman or the farmer who is standing in the paddy field. They all do this. I hope some of you may be agreeing with me, right? Okay. Now, what is going to be our body resistance? A simple, you can see, if it is dry, we can withstand so much of ohms, 70,000 to almost 1 lakh ohms our body can withstand. Wet, not dry, 5,000 ohms. If you are completely wet, 700,000 ohms only. Whatever our body can withstand when we are dry, from there it is only just 10% of resistance our body can offer. When our body is wet, we can offer only 10% of resistance. It means we become very good conductor when we are wet. We become a very good conductor when we are wet. See here, there is one simple representation. Oh, sorry. That ear to ear, hand to foot, dry skin, wet skin. So how the electricity flows into your body? See, there are two things are required. No, one part is touch, where you are touched. Whether you are touched the electrical source through your hand, through your leg, or through any of your body part. Correct? No. The energy needs some kind of route for entering your body. That can be anything, hand, leg, hair, anything. Okay. The shortest route, more the current. As you travel, so you can see the ohms. Huh? As the ohms are increasing, the amount of current is reducing. V is equal to IR, I is equal to V by R. So this is this the basic formula you all know. So how the electric current pathways, how it transfers, like you have touched some source. You can see there are 4 pictures. There are 4 pictures in the slide, correct? No, A, B, C, D. C and D are put together. If you take the case A, the source is touching the source used by his left hand, and it is earthed through the circuit is completed through the right hand. In the case of B, the source is from right leg and circuit is completed, grounded through left leg. In C and D, the source is touched through the hand and grounded through the leg. Okay. If you are allowing the current to pass through our heart and lung, it is the most serious case. It is the most serious case. When you are allowing the current to pass through your heart and lung, it is the most serious case. As such, our heart itself is developing some kind of electric pulse, so that it is always pumping. Correct? No? We all know. We all know that our heart itself, its no chamber is developing, is producing a pulse, so that our heart is functional. And I hope you all know about Dayanidhi Maran, Kalanidhi Maran, both the Maran brothers. Kalanidhi Maran is ruling Sun TV. Dayanidhi Maran, brother of Kalanidhi Maran, who was central minister for quite some time. In his tenure only, he made that 1 rupee, 1 India. From Kashmir to Kanyakumari, you can call with 1 rupee. That is done by him only. His father was having a severe. He is dead already. His father, Murasli Maran. I hope his father is Murasli Maran. He is no more now. It just suddenly come in my mind. Yes, he is heart patient. He was having a pacemaker. He was having a pacemaker for several years to keep his heart operational. He was artificially pumping his heart. So types of electric hazards are still continuing. Yes, we are seeing the piece, if you remember. We are just going through that one by one. Damaged or bare wires. This is one of the biggest cause for electrical hazard. Damaged or bare wires. Fault current may travel through a body, causing electrical burns or death if power supply is not grounded. If the power supply is not broken. If there are live parts or bare wires. Okay. So this is one of the cause for the electrical hazard. And most of the bare wires are with the part of equipment. You might have noticed this. You take the case of your hand tool, or you take the case of your building set, or you take the case of your temporary power supply. There are 3 pictures are shown here. Okay. The temporary routing of power supply. As far as possible, we are also trying to route the cables overhead. Correct? We are also trying to route the cable overhead. Some area it is not visible, where you lay the ground on the ground, or you tie the cable to some structures, or you tie the cable to some equipments, or some temporary poles. Those areas are always vulnerable for damage. See, the insulator is a non-conductor. It is protecting the current so that we are not exposed to the electrical energy, but it can be damaged very easily. This insulation can be damaged very easily. Even though you are using a double insulated cable or single insulated cable, the damage is possible very easily if there is a object which is crushing the cable, or is there a sharp object which is touching the cable. Okay, and cable and the power tools I don't have to mention because it is a poor way of carrying. You all know most of our gentlemen, most of our worker what they do the moment the job is finished, you'll not be ready to go and deplug the cable. You'll not ready to go and deplug the receptacle. What you will do, you'll just simply pull the cable, or you will, if you want to take the tool, you will pull the wire so that the drill is coming to his hand. You try to drag. Correct, no? Improper repair. Improper repair. So needless to mention, yes, in a hurry, always when the maintenance team, they want to support production, or the maintenance team, those want to support construction. If they do a quality repair, then these kind of problems can be solved. But in a hurry, what they do, always try to cannibalize the component. They'll try to remove the plug from one repair tool, put it to another. The wire may be short. They will do all makeshift arrangement to make somehow it is serviceable, and finally end up in trouble with some loose terminal or improperly fitted terminal or poor cap. Is the screen is visible properly? Okay. Okay. See, these are the simple example. When we are trying to pass the cable, we use a wooden plank for supporting the card. But how the card is supported? The card is supported with the help of a nail. The problem comes here with our confidence level, not competency. We are so confident that no, I didn't hammer the nail too much. I slightly bent so that the cable doesn't move away. But what will happen when you are using a nail for holding the power supply cable? If something is fallen over the nail, somebody stepped over it, or some object is fallen over the nail, then there is a possibility of further crushing of cable that may damage the cable, that may overheat that area. There can be some kind of there may be some kind of overheating that particular location. Because of that, insulator, outer insulation will go bad, or inner insulation will get damaged. Okay, something will happen. Now, most of the electrical hazards are related with the poor selection of cables. See, you need to have a 14 gauge wire, or you need to have a 10 gauge wire. The 10 gauge wire is costing more than the 14 gauge wire. So what do? You go for the lesser option in terms of saving some money. But what will happen in due course? You are going to lose the whole thing. See, whenever we have a setup, either you take the case of domestic or industrial purpose. Today I may not be having, or I may be having only one AC in my home. Tomorrow I'll have 2 ACs in my room. Both rooms I'll have AC. I have one fridge. Tomorrow I may keep one more fridge in master room. See, in most of the house you can see every room there is a TV now. Correct? No? Before we'll be having one TV in one street. When I was studying in I was just talking about 80s. No? One street, one TV. Now we have come to that situation. We have TV in every room. One TV in hall, one TV in bedroom. Correct, no? In some houses, I see. In some houses, I just happen to see that every room they have TV. Okay. So what will happen if this is happened to your expansion, and whatever wiring you did during the construction time, if that load is not tolerated properly, all those wire will have overheating. Yes, when the load is increased, it will have some kind of symptoms. Correct? No? Like if you have a sugar, either you have sugar or you have BP, our body is showing some kind of symptoms. Correct? No? All of a sudden, I suddenly have severe headache, or I feel extremely tired. Okay, sudden headache, sudden tiredness, you can just link with blood pressure and diabetic, correct? No? Similarly, even these wires also will give up when you were constructed 10 years back and you are keep on expanding your organization, you are keep on expanding your domestic requirement, you are adding up another machinery in your shop floor. Using the existing wiring circuits, existing system means these wires will have some kind of blood pressure and diabetic. And if you are not treating this blood pressure and diabetic of your wiring system, they will finally become a fire hazard for you. Okay. So you all know that as the gauge number goes down, it can take more capacity. Correct? If you like from zero is the more highly what do you call it? Strengthened wire. Like 14 is 15 amps, 12 gauge is 20 amps, then 0 is more. Okay. Power strips. This is what I was talking about, overloading. See, we always overload in, see, as such, there will be one socket. From that socket, you'll be using one extension box. This extension box will have 4 sockets. All these 4 sockets will have 4 extension box. Just imagine the amount of load. Just imagine the amount of load with multiple extension. See, that is what in some projects, they will not allow any extension. There are some projects very stringent. Even when I worked in abroad, I was working in Kuwait for a project known as Clean Fuel project, where extension is allowed with only one socket, only once. You can't have multiple extension. You can have extension from that socket, only one extension with one socket only, even that socket will have ELC. If it is not there, just imagine, even then we do some kind of Alibaba work, we do some kind of work without the knowledge of client. But imagine there we don't have such stringent, strong rules. So what our people do, from that extension, you will have one extension cord. That extension cord will have 4 sockets. All the 4 sockets will have 4 extension cords. Correct, no? How the overloading takes place, that you can easily guess now. Yeah, this is another one problem. Portable heaters, or you take any kind of portable appliances. For example, here is a picture of heater is shown. You take the case of hand tools. How hand tools are dealt, how hand tools are handled in your organization. Just imagine. Wherever you are working, maybe a shop floor or your engineering workshop or a small scale industry, just imagine how our people are handling the power tools. Just imagine. See this here we see that how the overloading of socket, how overloading becomes an electrical hazard. So these two are coupled together, and we are because of overloading, overheating taking place. Because of overheating, insulation becomes weak. Because of insulation becoming weak, that catches fire. That is catching fire. The fire become a source of explosion. Yes, this is all like a chain. This is all like a chain, links of chain. Okay. How much distance we should maintain from overhead power lines? How much distance we should maintain from overhead power lines? See, here a small table is given. Up to for 50 kV, 10 feet safe distance required. 50 to 100, 15, 200 to 350, 20, 350 to 500 kVs, all in kVs. All in kVs for alternating current. How much distance we should maintain? Minimum clearance distance we must maintain. The question will come, sir, follies are so high. Then how much distance I should? How can I measure this height? Correct, no? I don't know. What is the pole height? How can I maintain this 10 feet, 15 feet, 20 feet? Correct? The question will come to your mind. If I am using, I can't go on with a measuring tape. or I can go with some other measuring technique to see the distance, safe distance. Correct, no? This question will suddenly come to your mind. Okay, 10 feet, I agree. But how I am going to measure this 10 feet? The question will come. Okay. Whenever we have any overhead power lines, we must always, and if you happen to have a extensive construction work in that area, okay, 50 kV or 100 kV, 400 kV, the high voltage aspect always we must keep in mind. We must always consult our work with the EV, understand or have the data with you. What is the height of cable? Where is the sagging point? See, the cable can't be in straight line, correct? No, the cable cannot be straight all the time. It will sag. Depending upon its length, it will sag. Okay, that sagness we know. Where you're going to operate, your boom length, you know. It's a good thing. Your equipment, whatever boom length, you know, you will come from your control panel itself. Yes, maybe Hydra, even these modern Hydras nowadays, it has its own readings. In the old version Hydras only, we can't measure what is the height of the boom, what is the length it is extended. We cannot know the older version, but the newer version, everything is digital and we can easily know. From there, we must calculate. Okay. Now we saw the extent. We saw in extent that how what do you call it? The different electrical hazards with regard to the voltage, multiple load. Then now, how we are going to protect? How we are going to protect your system? We are going to protect our system by using ground fault circuit interrupters. Like we all know, we know about ELCB, we know MCB, we know RCCB, correct? There are different kinds of variety of systems are available in protecting workers from this electrical energy. But the present as and date, presently GFCs are most advanced, and it is much safer in comparison with ELCB and other circuit breakers. Okay. It is designed to protect people from electrical shock, detects ground fault, and interrupts electric current, limits duration of electrical shock because it trips at 0.13 milliamps itself. If you can recollect the table which has been discussed some time back, that at 1 milliamps, what will happen to our body? At 10 milliamps, at up to 50 milliamps, then 52, the other larger figures. We saw the effect of milliamps on the human at different conditions of milliamps, correct? No? Similarly, this GFCA, you see the GFCAs are the advanced GFCAs are available now. If there is a potential difference of volt, what is being used, if there is a potential difference of the voltage, that time also will trip. See, the one thing, if there is any ground fault, will trip, correct? No? Normally, for our circuits are completed through phase and neutral, correct? Our circuits, our electrical circuits, I'm just putting in a very layman language, that our electrical circuits are completed in 1 second. Yes, here one eraser keep coming. Okay. The simple thing that phase neutral, these two are completing. When you are keeping a load, you are keeping the load in between. So the current flows through the load, completes through your neutral, that backs to the your MDB, main distributing panel, or temporary distributing panel, something. Okay, circuit is completed. If there is any fault, it is routed through the earth. Wherever you are going to use POS, correct? No, this is normal. And this GFC advantage, if you are putting this GFC in between, see, your source is available. Your source is one part. Your load is one part. In between, if you are keeping GFC, if there is any potential difference also, your GFC will trip. So that no question of exposure of electrical shock or electrocution. by the workers. There are different types are available, right? There are different types of 3 types are available: receptacle, GFCI, temporary, portable. The yellow color one, the one which I was talking about is in between, temporary or portable GFCI. This has, see, all 3, they have a test button. Okay, all these 3, what you are seeing the screen, one is yellow color, which is lengthy in comparison to other 2. This is a portable GFCA. Wherever you want to connect in your organization, as depending upon your organization requirement, you can go get it inserted to the receptacle available on the workplace. Then route your work from the other end of the GFCA. Okay, and this GFCA is having a test button, and we must press the test button before starting our work every day. Not that one day, every day. Connect your load, press the test button, it will get tripped. Then reset, do your job. Okay. I hope this GFCA term is clear to you all. Anybody sign it out? GFCA is for only industrial purpose or domestic also you can use. See, that's what I'm saying. See, now there are a variety of models are available, GFCA. GFCA, not only for industrial purpose, even for domestic purpose also it is available. And as the now we are not going for a much demand of GFCAs. As the demands are raised, it may even be there will be some kind of technology inventions, and it will be much cheaper also. I don't know how many of you remember sometime back, not sometime back, means some years back, somewhere in 2015 or 16. A gentleman from Chennai, he's invented one white box. Anybody remember? It was displayed in news only. 2015, he developed a white box. If you route your domestic supply, like we have a MCB, correct? No, from the MCB, you have 2 service or 3 service. From the EB, it comes to the main board, correct? No, and just since somebody's asked a doubt about domestic, it just come in my mind. See, like for domestic purpose, we take the power supply through the service line. It comes to our main junction box, correct? No, it comes to our main junction box. From there, you have a series of wiring done for meeting a requirement for your hall, bedroom, kitchen, etc., etc. Okay. This gentleman invented a white box. If you route your entire energy through this white box, even if you happen to touch the bare wire, you will not get shocked. But somehow this thereafter, I don't know what happened with that white box. If somebody interested, you can just type in Google and find out white box invented by Chennai engineer. So you'll find some YouTube videos available in YouTube by Tandi team. Okay, it is very much applicable for domestic purpose also. Okay. Now, how we are going to protect? See, one part we saw now GFCA. Another thing, when we use extension card, we must use extension card with nowadays you can like fuse box. There are individual fuse are available with the extension card also. Correct, no? The moment you cross the capacity so much, like you want to take only 2 extension or 3 extension, as per your load requirement, you have the extension box designed with respect to the master socket. Okay. Then anything if you go beyond your rated requirement, this will trip automatically. Okay. And hand tools are mostly damaged because of misuse. See, sometime back in our one of the webinars also we were discussing about incident accidents. And I think you can just recollect. You take the case of any accident or incident, only 2 things are possible: either unsafe act or unsafe condition. And if there are 100 incidents in our organization, out of 100, 80% of them are related with unsafe act only. Unsafe condition are only 20%, the remaining 20%. Majority, 4 times of the unsafe, 4 times of incident accidents are because of unsafe act only. The hand tools, I hope you can just recollect it. See, since most of you are in industry only, you know. The worker will try to pull the tool by pulling the cord only. Correct? No, if it is somewhat far, you will not get up and go try take the tool by catching the body. No, you will only pull the cord. You'll pull the cord. But what will happen? If it is new, the damage is going to be less. As it is already used, frequently used, there will be some kind of loose terminals. There will be some kind of loose terminals, or one second, gentlemen, 1 second. Sorry, sorry. See, so what will happen? Our people, you will try to pull the cord, or just imagine they are working different elevations. Some scaffolds are built. So one gentleman is working above, one gentleman is working below. What you will do when you ask him to pass the angle grinder or portable drill, or the test equipment maker, whatever you have, the moment you tell what you will do, this fellow, instead of using a lifting bag, you will lower the tool using the cord only. Correct, no? Those who are from industry, you might have noticed these kind of activities are happening outside. Okay. Idea is to minimize them. Not by give them lifting bags. Sir, I don't have proper lifting bags. No problem. Use that cement bag. No problem. Use sandbags. No problem. Use gunny bag. No problem. Put the tools in some bag. Use a rice bag, 25 gauge rice bag. No problem. Use a 25 gauge rice bag. What is available in your site, sir? My management, no, they are not allowing me to spend so much money for lifting bag. No problem here. Don't really use any kind of system. Rice bags, 25 kg. Go to Kailangadai, no problem. Take 4 or 5 bags, put the tools, use a rope, get the tools lifted up so that the incident accident because of faulty tools can be minimized. Okay. Follow safety tool tips. Follow manufacturing instructions. Correct. Never remove the guard. Whatever we supposed to do and don't, ensure our team is following that, our workers are following that. Okay. See, these are very few common examples. These are the common examples of misused equipment. We use some makeshift arrangement, tie them with nylon rope, or use insulation tape. Something will do. What will happen? See, at the first time, nothing may not happen. When you're doing this kind of makeshift arrangement in a construction site, the O&M projects are different, construction projects are different. Agreed, no? The O&M project and construction projects will have their own advantages and disadvantages. In construction, even though you and your team is interested to do somewhat safe, but equipment are not available. If you want to buy the equipment, you may have to travel to the town, or you may have to go to the nearby city. Nothing is available in the village area. Because I have visited some of the construction sites in Karaikal. Okay, so where the same problem reported by the workers. There I was suggesting this rice bag business. I was telling them rice bag. Forget about lifting bag. Why you are worried about lifting bag and ropes, nylon ropes with lifting lug? Our idea is to do the job safely, use the available resources, so that we are minimizing the impact of incidental accidents. What will happen in some cases, you know, that you all know the plug will not be there, they'll insert bare wire, correct? No? You'll take the wire, you'll insert the bare wire, use the matchstick to fix the wire, correct? Or how many of you did so? Okay. So these all are possible in a construction site, but idea is to take utmost care so that nobody is injured. But if some injury is taking place, only safety and supervisor is going to be blamed. Okay. Okay. What we said so far, do's and don'ts, same thing it has been listed. Never carry a tool by cord, never yank. Don't try to pull the, okay. Keep the tools away from heat, oil or sharp edges. Okay. And when not in use, remove the tools. And do not hold the fingers on the switch button while carrying a plugged-in tool. Use gloves and appropriate footwear. Store them in dry place. There are some do's and don'ts are given. Don't use in wet and damp environment. Keep working areas well lit. Ensure that cords do not cause a tripping hazard. So these are some common basic certifications only, so that we don't cause any electrical incidents. At the same time, we don't cause any personal injury also to the worker. Okay. Now, as I was mentioning about now O&M projects, so construction is one part. The amount of lockout tagout is much more in case of pre-commissioning stage, commissioning stage, and O&M stage, and for O&M projects. Okay. So lockout tagout, this you might have come across several times. So nothing special here also. Keep the source locked and put a tag. Okay. So if the source is electrical energy, it's very easy for us to do a logout tagout. If the source happens to be a dynamic, like if it is happen to be a liquid or if it is happen to be a gas, then we have to take much more safety precautions. Here, in case of electricity, the process is very simple, but severity is much higher than the liquid and gas state. See, if you are working in any 10 kV line, 10 kV and above, or forget about 10 kV, even 440 volt, which you are using for the building set, building generator, what you are using. Nowadays, we have building rectifier, the small one handled. There is no much problem. Before we used to have that 440 volt building generators, bigger one. So those things are always potentially dangerous, right? No? So we must ensure proper lockout and tag out. Lock the source, tag the source. In simple term, lock the source and tag the source. Tag the source with details, your name, contact number, purpose, date, etc. So that in case I have any query, I can just come and clarify with you also. Or if I want to put a lock, if like a mechanical and electrical team, both are working on common location, both are working for a pump. One gentleman is working for a pump, other gentleman is working for another motor. But the source of energy is common for both of them from a common substation. Then we'll be using the ASP lock, where multiple lock we can put in single lock. Correct? No? So you put your lock, I'll put my lock, and I'll have my tag, you'll have your tag. So at the end of the day, we know each other. And whoever has put the lock first, he is having full right to remove at the last. Or if he is removing it before than me, then you will inform me and then remove, so that anyway my lock will be on there. Okay. I think there is no much explanation required for lockout tagout, because most of you, I think, being a HSC professional, we all know about lockout tagout. Okay. Now, what do you call, variety of system is available. Lockout tagout also. Different colors of log, different colors of tag. For mechanical team, different colors of log. Tag itself is different. The moment you see will come to it is put by whom. Okay. Now, power source identification. Okay. Recently, I've been to audit for one of the company in Solinganallur. See, the moment we open the control panel, we must have an idea what this control panel is caters for equipment ABCD. Correct? No, there has to be some link. The control panel must have some kind of layout so that the operator knows where I have to go and switch it off. If there is any problem, and I have 10 machines, if the panel doesn't have any marking, where I am going to switch off, what I will do for safety purpose, I will switch off all the 10. Correct, no? So always, if there is any panel, control panel, whether it is small or big, we must mark all the breakers. We must label them so that it comes in use for us. We can carry out proper lockout and tag out we can do. Okay. Now, this employer requirement, here it is mentioned about OSHA. Yes, most of the I just took from OSHA. And apart from that, there are some more references we'll see in subsequent slides. Okay. So the employer requirement is to protect worker. The employer requirement is to protect worker from everything. In general, is everything. Power line or electrical. If there is electrical source, provide them GFCI, implement safe procedures, give them quality power tools. See, if you take the case of power tools, most of the tools are with dead man switch. I hope you know the dead man switch. The spring-loaded switch, operating switch. The moment you leave your hand, that it breaks the circuit and your grinder or drill stops then and there. Correct? No? Before it was not like that. You have to select a switch. For on mode, for on and off, you have a switch for making it on and off. Nowadays, the switch business is no more. It is all a spring-loaded lever. You have to press and hold the drill. The moment you happen to leave the machine, even accidentally, it will stop. Because there are several incidents occurred in the past. While operating, the operator dropped the machine accidentally. That caused him severe injury. Correct? No? Either a drill or grinder, the moment you drop, it falls on your leg or falls in your hand, lap, somewhere, any of the body part. So that will create some injury. Correct? No? Because of the injury, and if you happen to be in an elevator working platform, if you happen to jump or you lose your balance, then falling hazard is going to be a secondary hazard. So always ensure your hand tools are qualified and it is having the appropriate safety requirements. Like proper guarding, training. You give them training about operating do's and don'ts, what is LOTO, make them understand the proper power sources. These pictures you can easily understand what is right, what is wrong. Correct? No? This picture you can easily understand what is right, what is wrong. So here one case, completely wet condition, cables are available. Damaged. Here you can see the damaged tools. You can see a damaged. There are two pictures. Okay. So one with the cable totally crumbled. You can see the damage to the cable. Other cases, damage plus wet floor. Here also very clear. A mop is just kept onto a power supply panel. Other power supply panel, nothing, marking, nothing. Now, what are the requirements are around us electrical safety? You see, like we talk about OSHA, we talk about NAFA, and we have our own regulations also. Electrical Safety Act 2003. Okay. Yes, the slide is become very small. That part also you can see. Electrical Inspectorate, TNEI. Our website also clear. Even for Tamil Nadu, there is a website tnei.tn.gov.in. Tamil Nadu Electrical Inspectorate. TNEI. You can check these websites also. What are the requirements are we supposed to follow is given. And NAFA, you see, most of the things we are taking from NAFA and OSHA only. Okay. Most of our requirements we just we refer OSHA, NAFA, and in addition to that, whatever is applicable, whatever more needed to stringent our requirement, that has been also added. Like we have Tamil Nadu Factories Act, correct? No, 1948, 1950. Similarly, we have Electricity Act. Okay. So whenever any audit performed, also these audits are performed in accordance with these acts only. Next. So now, what are the different causes for an electrical accident? Causes for unsafe environment, unsafe work practice. Okay. Now, See here, I have listed some A, B, C, D, E, F, G. These 5 cases I just taken down from the website www.tnea.tn. This is the this I just took from the incidents only. Under this category only, the accidents, electrical related accidents which are taking place in state and central, both are captured in this heading only. Even if you refer central website also, in that also same thing is captured. Snapping of conductors, accidental contact with live electrical wire, violation, neglect of safety measures, defective appliances, inadequate lack of maintenance, unauthorized work, other reason. Okay. Now I have a question to our participants now. Out of this A, B, C, D, E, F, G, which are unsafe, which are coming under unsafe act, which are coming under unsafe condition? Can someone mention? Is anybody? You can just give a view through the chat box. See, there are A, B, C, D, E, F, G. Out of this A, B, C, D, E, F, G, which are unsafe, which are coming under unsafe condition, which are coming under unsafe act? Is the slide is visible? No, slide is visible. I hope the slide is visible, clear.
Yes, sir. Yes, sir.
Can you give your views if anybody interested? Because otherwise you'll get bored. No, every time I only keep talking, so you get bored. Yeah, somebody already replied. Yes, thank you. Thank you for those. Okay.
You asking about that unsafe act and unsafe condition, right, sir?
Exactly, correct. Out
So,
of this A, B, C, D, E, F, G.
Okay. So person walking without safety harness is unsafe purely or more than 1.5 meter.
No, not that. No. Here, see, there are some 6 conditions visible, right, in this slide. Snapping. Okay, one by one we'll go now. Snapping of conductors. Is it unsafe condition or unsafe act? Yeah, somebody replied. The snapping of conductors. Huh? See, the conductors, like you might have seen some kind of sparking taking place in the street light pole, correct? No, sometimes sparking taking place or wire is hanging. Somebody is written correct. A, B, C, F, unsafe act. D, unsafe condition. Yes, D is unsafe condition, correct. D is unsafe condition, correct. A also unsafe condition. See, A also a unsafe condition, because I hope some of you might have watched the news also during the rainy weather or during stormy weather also. The light pole collapse, wire is hanging, wire is touching the water on the ground. Somebody accidentally touched the water or touched the water and got electrocuted. Correct? No, this also we saw in news, I think a couple of weeks before. Snapping of conductors. Conductors got snapped from its location. Snapped, broken from its location. There is an unsafe condition. Okay. Accidental contact with live electric wire oblique equipment. This is linked with A. See, if accidental contact, whether it is accidental contact or intentional contact, both are related to unsafe act only. Neglect of safety measures, unsafe act. Unsafe condition. Inadequate or lack of maintenance, unsafe condition. Unauthorized work, unsafe act. So like that, we can just see whatever the conditions are available, we can always correlate to these two. Like any incident accidents will have either the root cause might have a human error or might be a unsafe condition. See, unsafe condition because of nature, we can't do anything about it. Correct? No, suddenly there is a heavy rain, heavy wind. Because of heavy wind, pole collapsed. Okay, because of pole collapsing, wire got detached from the pole and touching the ground, somebody electrocuted. But here, the unsafe act from the EB part, when they know the this kind of weather, he should go off switching off the power supply in the entire zone, so that nobody is affected. Even though we are suffering without the electricity, that suffering is far better than losing somebody's life. Correct, no? I hope now to some extent is clear now. So we'll just move on further. So how we are going to protect these accidents? So we discussed several things. How accident taking place, what are the different types of hazards, different types of classes, unsafe at unsafe. How we are going to protect now? How we can protect the protection? The best protection is possible by effective training and implementation of safe work practices. Okay. Effective training and implementation of best safe work practices. Like if there is a lotto, and lotto must follow. And what is lotto should be understood by the people. Correct. See, the worker, if you don't know what is lotto, and you keep on telling him lotto, you'll think that what is lotto? Okay, bring me some tea, coffee in that lotto. Okay. That action should not be there. Okay. And all the tools and equipments, whatever is available with us, it should be maintained properly. As far as possible, don't do the makeshift arrangement. From there to here to there. Okay, somehow you want to keep the job running, moving. Okay, that never do. And energize, follow the safety precaution while working near energized line. And PPE. See, we all know PPE is the last line of defense in any hazard control is or PPE. And we must use this PPE effectively. For namesake, we should not use any PPE. In the coming slides, we can see how PPE is going to support us. I'm just slightly late. There are a couple of more slides now. I'll just quickly wind up. Synthetic clothing. These are not supposed to be worn at any cost. These are not supposed to be worn because they can melt easily. Acetate, nylon, polyester, polypropylene, spandex. These kind of materials should not be worn at any cost. Then what should be worn? Flame resistance clothing. We should try to wear flame resistant clothing. To some extent can protect us. What is flame resistant clothing? Okay. To know what is flame resistant clothing, we must know what is calorie. Calorie is the amount of heat needed to rise the temperature of 1 gram water by 1 degree. This we all know. Correct? This is 1 calorie. Okay. Yes, since thermal energy is always mentioned in terms of calories. To realize what is that 1 calorie, a simple exercise is given that you hold your finger in the blue part of the flame in a butyl lighter, that cigarette lighter, normal cigarette lighter, just lit the cigarette lighter, hold your finger in the blue part for 1 second. Okay, that is just equivalent to, yes, if you raise your index finger, consider your index finger is 1 centimeter, no? It is going to be 1 square centimeter, correct? If you are just trying to keep, so whatever energy you can feel, heat you can feel, that is going to be 1.2 calorie. Just to make us to realize. Okay. Now, the FR retardant clothing, fire retardant, fire resistant. Okay. So here also there are plenty of varieties are available. You can just see in the subsequent slides. See. So these are the different hazard categories 0, 1, 2, 3, 4. Okay, and in the next column, what is given is the thermal energy, the calories 0 to 1.2, 1.2 to 1.4, 4 to 8, 8 to 25, 25 to 40, over 40. Dangerous. Over 40 is dangerous. And these are the, like we were talking about arc blast. Correct? No? Arc blast. Okay. So those things are always dangerous. How we should go, what kind of PPE we should use, we can see in the subsequent slides. See, for 0 hazard category, normal eye protection, air protection, long sleeve shirt, pant is enough. As the category is rises, changes, you need to have arc rated clothing, face and head protection, and flash, shoot, and hood. As flash, shoot, and hood, or flash, or blast. If we happen to work in that scenario, we need to have a high standard of VP. You can just see in the subsequent slides. See, for 0 category, simple. Head, full sleeve, pants, some shoes, simple. For category 1, same pant, shirt, some gloves are handed, and face shield is attached to your helmet. Previous case, no face shield. This case, some face shield. Next case, the arc-rated face shield. Okay, and your uniform also slightly changed. With it is going to withstand 8 calorie plus, and it is 825 means you can just see now there is a separate. There is no face shield now. He is wearing a long sleeve pant with the flash. This is a complete flash shoot. This is the flash shoot. Okay. For next category, how is going to be 25 to 40. For above 40, we can see in another slide also. It is going to be what you call the flash shoot. Flash shoot. Okay. Now, this is the latest IS available for us for using the type of gloves. IS 4770 1991 latex rubber seamless type. Okay. Now, how to check the quality of these gloves? Okay. How to check the quality of gloves? Okay, you can just see the subsequent slide also. So these are the different varieties of gloves are available. These are the different varieties of gloves available as per the EN and ACM standards. And here the voltage also given. Voltage also given. And this glove will have a tag. Tags are certified in the laboratory. These are certified in laboratory, and then these tags are given. Okay. And these are the classes 1, 2, 3, 4. Marking on gloves. So each marking has its own meaning. See, this is a risk category. 0, 0 means risk category. We saw the risk category. 1, 2, 3, 4. So these gloves markings are available. We have to choose the gloves depending upon the risk category, what is there in our side. Okay. Yeah, gentlemen, is it clear so far? And just as I said in the beginning, it is a very vast subject. We need to have at least 2-3 days. Yeah, someone said okay. Thank you, Rajan. Thanks for your feedback. Now here you are going to give me a reply now. Okay. Now I'm going to wind up the session now. Before winding up, I'll ask some question, then we'll wind up. What is electricity? There are some options are given A, B, C, D. So what is going to be our option? You can just type your option. What is electricity? There are 4 options are given. 4 options. Somebody replied. Yes, he is right. Yeah, many are replied. Okay, thank you. Just move on. Yes, whoever is typed is right. Then electrocution means. Yeah, correct. Thank you. What is electrocution? Yes. Yes. Yeah, correct. Correct. Yeah, right. Yes. Arc flash or arc blast can reach maximum temperature up to 350 degrees Celsius. Sorry, Fahrenheit. Yeah, somebody replied. Yes. Yeah, true. No. This is the answer. See, remember, we were mentioning 35,000 maximum it can reach. See, it can reach arc flash or blast can reach up to 35,000 degree Fahrenheit. So much of heat. Just imagine for 100 or 101, 102 degree Fahrenheit, our body, we feel so much tired, we feel so much of temperature in our body, we feel hot. Yeah. Yes, somebody replied correct. False. Yeah, somebody replied correct. Now next. Which gauge of wire will carry the most current? There are many answers. Yes, there are many are replying, but the correct answer is 0, 0. You remember, obviously, see, as the gauge goes lower, it carries more current. As it goes 0 towards 0, it carries more current. What does the GMCA stand for? I hope this you all may say no. Yes, you all will tell. Tuck. Which of the following is a safe practice? This also will, I think you all will reply. Who is responsible for ensuring that overhead power lines are de-energized? And this also, I think most of you will reply. This also, I think you all reply because now we saw in the beginning, correct? No. This is the employer responsibility. Remember, one of the slides we were discussing. It's a legally employer responsibility, but employer may not come there. He may substitute his project manager, or he may substitute his maintenance manager, or he may substitute his electrical manager. But the responsibility is always lies with the employer. He can be put behind the bars. Okay, gentlemen. Actually, see, in fact, I thought of adding some more slides regarding the requirement for obtaining license. See, if we are starting maybe you take the case of home also. Even if you want to take a connection for your home, or you are taking a service line for your company, then you have to go for applying license. When you want to apply a license, or you want to renew your license, what are the factors you should consider? What are the rules you're supposed to refer? There are many things are given. Those things also I thought of sharing, but it is not possible anyway by the the time available with us. So that's why many areas I just cut short. Many areas I just cut short. I hope most of you might have understood. Any doubt, we can just always get back to us through our feedback link or through our mail. I think most of you are a repeated participant for us. Yeah, I'll download the photos and see. Okay. What is the number? Once you just saved your photo. Let me check. Yeah, gentlemen, any doubt? Yes, in the meanwhile, I just checked his photos also. Yeah, see, all the time it has been informed to our participants that the feedback link, please complete the feedback link. And once you complete the feedback link, the presentation will be shared to you automatically. It's shared automatically. And you give your feedback also. What do you want more? What is required? No, correct. See, that's what. So somebody's asked for a doubt. I'm being to an audit for the Pinnacle Crest apartment, which is built by the Bashiam builders and Bashiam. See, they have all these factors considered at the time of construction itself. At the time of construction itself. I'll just stop sharing the screen now, so that somebody's asked for a doubt. I'll clarify his doubt. He raised a doubt through chat box. I'll try to clarify his doubt. Yeah, gentlemen. Yeah, gentlemen. Any other doubts? Yes, I saw only one query in the chat box so far. Any other doubts? Okay. Then procedure for hot flash shoot calibration. Yes. It's available. See, all the arc flash shoots are supposed to be tested. Even when you buy from, when you're buying at the time itself, you're supposed to give us a certificates. Actually, there are some couple of videos also available, how it is being done, how the testing is being done. I thought of showing the videos, but time is very much limited. And somebody who asked for a doubt regarding that picture, leave your mail ID or you just call us, you convey your query through our mail ID, that IINVTY@gmail.com, so that we will reply. There was an HT line is going on from thermal power station people. See, that's what, see, all the overhead power lines, here I have not seen. See, if there is any potential of breakage of line, they always put a barrier also beneath, like we use safety net, correct? No? When we are working at height, we just connect safety net below the elevated portion, correct? No? Similarly, even for the overhead power lines, there is a safety net. If there is any disconnection or snapping of conductor, snapping of cable from the pole, the cable will not touch the ground. It will be just lying on the net itself. The doubt raised by, yeah, I hope I cleared your doubt now to some extent. The doubt raised by Rajan. Yeah, Rajan. See, there is a, remember if we provide details, yeah, I will do that. That's what I'm saying. See, you always write to our corporate mail ID, IINVTY, IINVTY corporate@gmail.com. I just type here so that we'll share, because it is available. Because I have seen this in abroad, the safety net which I was selling, with this I saw below the cable, they just put a net. Where is it there? Okay, just send this now. You always raise your queries through our mail ID, IINVTY corporate@gmail.com. Shared a photo, that also I'll reply him. Share a photo because I could not see the photo now. See the photo, I had to leave the session now. Okay, gentlemen, I take this opportunity to thank one and all who were with us from the beginning and till end. And we'll have a similar session in coming week also, and with more details with regard to rules and regulation and other safety requirements. Thank you, gentlemen. Thank you. See you all in next week. You'll get our feedback link through our mail anyway from our office. You'll get the feedback link. Thank you, gentlemen. Thank you. See you. Bye.